Alright everybody, if you haven't had a chance to yet, go ahead and make a new file. I'm going to start with give me 10 minutes here. I'm going to explain blueprints and we're going to go from there. And then we'll try my best to kind of explain this. So I apologize, this is going to be more lecture-y as opposed to actually demo-y, but then when we finish this lecture, we're actually getting to some demos, etc., etc. So, welcome to blueprints. Blueprints are, I think they're cool because they open up the door to what you can accomplish with the engine as a whole. They're designed to be, let's see if I can change my perspective here. There we go, I think that's a little bit better, isn't it? Let me actually move my camera here. Let me pause for a moment. Alright, I'm back. So, blueprints are designed to be incredibly flexible, and probably to their detriment. They allow people who are creatives to make a game without having to look or worry about having a programmer on the team, at least initially, right? Especially when it comes to adding features to your game. So far, we've been learning how to do things like construct environments, how to build physics, how to create some of the visual aspects of the engine. But the environment is only really half the game. Now, most of your starting efforts should be focused in creating at least a testable or playable gameplay system, right? But we'll get more into that into the second course, as we learn a little bit more about blueprints after this week. The other half of your game is going to have to be the logic that essentially determines how the environment is interacted with. Whether you're climbing, whether you're flying, whether you're able to run, whether you're taking damage. It controls how the game is actually going to be played. And that's where blueprints kind of come in. So, as I explained earlier, blueprint is an asset, or it can be set at the level stage, that contains information and instructions for how the game is supposed to operate and run. We can do things like keep track of health, we can track energy, score, time, anything we need to keep track of. And we can keep track of things like logic puzzles, or game logic for when we've picked up a key, or we completed a puzzle, or when the door is supposed to open, or when we've killed all the enemies, etc., etc., right? What happens when we complete the puzzle? What happens if I shoot an enemy? What happens if my character takes too much damage? What happens if I fall past a certain distance? So on and so forth, right? So, there are two main types of blueprints. We have the level blueprint, and we have blueprint classes. Now, I'm going to be killing my video here shortly to show the editor viewport, but once I do, it'll be easy to kind of follow along. A level blueprint is used to hold data for a particular level. So it's going to hold data like time remaining to complete the level. It's going to hold how many number of keys, how many things need to be accomplished on the map, etc. How many things you've collected on the level, so on and so forth, right? And it's also used to store instructions that pertain only to that level. I'll show you the level blueprint here shortly. For example, let's say there's a spot in the level where you have a bridge, and once the player crosses the bridge, you get something like that streaks across the sky, or like the bridge collapses behind the character and suddenly you can't go forward. Oh no, right? If that's a one-time unique occurrence, it would make sense to store it in the level, right? Because then we can store things like cinematics. We can store our one-time events in the level blueprint. And don't worry, I'll show it here in a sec. It would actually be, you guys see where I'm pointing up here? Right there. It would actually be right above my fingers there, right in the blueprints button. But the level blueprint is used to store information for a level that might run once and really only once. That's different than, say, a blueprint class. Uh, Blueprint classes, or BP classes, as I illustrated in the previous demo, are a way to turn any actor or any asset into something like a blueprint, and that allows us to make things like objects with specific behaviors or traits and specific functionality for our particular game. So let's say I was building some kind of weird Saw murder house, right? And I wanted to have something that flew out and tried to attack our character as it was doing something, like as soon as we got close. Well, let's say we also wanted the character to be able to like take damage and also not immediately blow up. So we give them a certain amount of damage. So we give that element a certain amount of damage that it does when it hits us. We give the character a certain amount of health. And so with the blueprint, we can specify how all of that works, how all of that moves, how all of that is going to translate into damage into our character. And once we actually put that into the world, we can place that element in the world and it'll behave consistently across the line. It'll behave, oops, I almost knocked over my water. It'll behave as though, it'll behave as intended because that's how we programmed it. Now, you'll learn more about gameplay systems design in the intermediate course, about not necessarily so much practice, but you'll learn a lot more theory when it comes to player-centric design. But the most important thing being here to take away from that is it's important to understand mechanically what your game is going to do, because your game's most important elements aren't necessarily the art, it's going to be the machine by which we generate fun, right? So let's say that that thing that hits us, the giant swinging, bat trap or whatever, hits us for 10 damage out of 100 damage that our overall character has. Well, we can specify that if our character gets below 80% damage, we take a 5% speed debuff. We change the animation system that then shows that our character is like hobbling or limping, and then we continue to do something like that. Maybe at 10%, the character is basically like moving at like maybe a third of the speed that they were moving, right? So imagine how many blueprints imagine how many blueprints you can create just trying to instance those behaviors, right? And let's say that trap shows up in multiple places. If we've got like this crazy Saw house, right? Imagine it on like at least 3 every floor, maybe in an array, or maybe 2 or 3, one after the other. Maybe we can break them. Maybe we can take the pieces and turn them into a weapon ourselves. Those are all scriptable behaviors, right? And the nice thing about blueprints is that you can use them to create as many of the instances and copies of this element as you need, right? So with one blueprint, you can make several instances of the same type of enemy or trap. Trying to think of other concepts that I can illustrate. So let's say that each of those swinging traps has their own health, and if we hit them, they do damage, right? Each of those blueprints that we drag into the scene would have their own copy of their own health variable. So instead of, like, let's say I damaged one of those traps, they wouldn't all get damaged unless we wanted them to all be part of an array, right? But one would be damaged, and they would all live independently from each other, right? That's an important concept that I wanted to get to. Every blueprint class gets its own copy of specified variables available in the blueprint. So if you drag it out from the content window again, those 2 blueprints are now 2 separate blueprints with their own variables that operate independently from each other unless told otherwise. So I think I might want to do something blueprint-wise in action here so that we can actually see something. So that was kind of a general concept of the blueprints. Let's go ahead and look at blueprints actually physically in the engine so we can get a better idea of what's going on. So what I'm going to do is I'm going to create a simple element. I'm going to create something that I'm going to start the game, and once the game starts, after maybe 5 seconds, the game is going to quit. Yes, that's kind of dumb. It's not practical. That's not something that you would want to do, but I wanted to illustrate kind of how it works so you have a pretty decent example and kind of an introduction to blueprints as a whole, right? So let's go ahead and do that. I'm going to go ahead and switch my camera here so you guys will be able to see the editor. And then if you feel like following along, feel free to go ahead. I'll explain the elements as we go. Alright, here we are inside the editor, and I'm going to go ahead and go up here into Blueprints, and we're going to go ahead and open the level blueprint here. Boom. Huzzah. Alright, so we are in this event graph here, as we saw in the previous demo, which is kind of our slate graph that holds all of our variables and holds all our nodes and lets us kind of create whatever we need. So if you're a programmer, logic in Unreal Engine can be scripted in pure code using C++. However, Epic has provided people who are not amazing programmers, like myself, this visual scripting system that allows non-programmers to script logic, and it's actually pretty convenient for people who may not be as well versed or as experienced as a programmer to make something towards their purpose, right? And the way that this scripting system works is you're allowed to connect nodes through flowing wires, very similar to the material editor. And this is predominantly the reason why I like starting with the material editor, because the material editor illustrates concepts that are similar to the blueprint system as a whole, right? You might be wondering why there's these two nodes kind of chilling over here. If you pay attention to the written area right here, this node is disabled and will not be called. Drag pens off to build functionality. These are just common nodes that Epic assumes that you're going to want to have anyways. We have our one ticky boy, and then we have our event begin play. I would argue that both of them are about as equal depending on what's going on. The first node here is, or rather, these first two nodes are event nodes. Event nodes are nodes that are activated when certain events occur. So, with an event begin play, that one should be pretty obvious. It's going to be activated by the event of the level first starting. That's how it works. The top strip of any event node will generally be red, and that's going to be how you identify what is your firing off event for any particular node that you're looking, or any particular blueprint system. And generally, I start reading my blueprints from the events to figure out how they're actually being fired off. Our second event node here is our friend, the Ticky Boy. I know it's... hold on, let me bring that up. This one is all too true. Who would win? A stable or optimized game, or one Ticky Boy? The reason why is the event tick can be incredibly expensive for a lot of things that you're doing in your games. But we'll talk about that when we actually get to it. Essentially, let me explain the tick, because the tick is going to be important to know later. An event tick that is activated on every tick of gameplay. So before every frame of the game is drawn, this is before we get a new frame on screen. Any logic that is connected to the event tick node is going to be executed. So the reason this is useful is because in this particular example, you can check, or you might be in a situation where you need to constantly check some kind of conditional that, if conditions are met or change, need to be responded to immediately, and especially if they have an immediate effect on the game. Alright, we're not going to use the Ticky Boy here. We're just going to use the event begin play. We can go ahead and delete the Ticky Boy and get him out of the way. So what we're going to do is we're going to create a scenario where our game is going to quit out after a certain amount of time. So as a consequence, any nodes connected to the event begin play node, we got rid of our Ticky Boy, will execute whenever the level first begins. That's pretty straightforward. The other side effect of using an event begin play node is everything executes immediately. So if we were going to do our quit game example, we would have to delay the execution of that node for the amount of time it takes for the game to actually run. Alright? So in order to do that, we're going to actually create some nodes that delay the execution of our exit so that we can go ahead and kind of work with that as a whole. One way to create a new node inside of this editor is to either right-click an empty space in the graph and then select a node from the menu. As you can see, by default, context sensitive is turned on. Newcomers I would say leave context sensitive on. Experienced blueprinters make your own dreams come true. Figure out what is going to work for you the best. I personally leave context sensitive on a lot because context sensitivity allows me to follow a workflow that lets me drag pins and lets me do a lot of work in a short amount of time. Let's go ahead now and actually create our first node. I'm going to go ahead and right-click the background, and I'm going to type in the word delay. Now, I'm not going to create a retriggerable delay. I'm just going to go ahead and select the delay. We need a delay function. So we see, perform a latent action with the delay that is specified in seconds. Calling again while it is counting down will be ignored. Alright, so we can see this has a little clock, which means that it is a latent function. Perform a latent action with the delay specified in seconds. So that's what a latent function is. It is a timed function with a certain amount of either delay or advance, depending on what we're doing with our game time. So, what is the task of the delay? The delay function is supposed to wait for a specified amount of time before the node fires and before it allows the flow of execution. So let's go ahead and talk about the node and what each of these pins mean and how to best manipulate them. So these nodes here are called pins. We have our execution pins here, and then we have a data pin here. We have an input pin over on the right and an output pin, or excuse me, an input pin over on the left and an output pin over on the right, signifying the natural flow of blueprints executing from left to right. A rule of caution for my foreign students, of which I have some of you. If you are from someplace or somewhere that reads script differently, I apologize. I didn't make blueprints, unfortunately. Blueprints read from left to right in most cases. I'm making this statement now because this has been an issue in the intermediate course where I have students who are trying to read blueprints from both ends, not being sure, or rather it's not explicit as to what end you're supposed to read your blueprints from. Generally speaking, you should read your blueprints from left to right when you are starting to learn blueprints because it makes it a little bit easier to understand what's going on. So, again, execution pins on the left side of the node represent the beginning of execution, and execution pins on the right side execute the end of that node. So, if you click on a pin and drag it off, it'll create a connection to another pin. Now, we cannot connect execution pins to data pins, as executions are not compatible with, in this particular case, it's looking for a floating point variable. That's pretty straightforward. I'm going to go ahead and connect the event begin play node with the input execution pin of the delay node here. As you can see now, our event begin play node comes to life. And now I'm actually going to input some information in this area right here. Now, you guys will hear me refer to this as a very specific name. Typically speaking, if you are looking at a data pin and that data pin has an area that you can actually put any particular kinds of code or a variable, or you can enumerate yourself, or you can change the values inside of the variable here, writing a variable function, or rather writing a variable designation inside of this little bar here, is called hard coding. Hard coding means that this particular number is hard coded to this particular duration variable. Hard coding is generally frowned upon, especially because you can't modify this particular code. So if I say set this for 3.0 seconds, I cannot modify this code because there is no variable to modify. As you can see, our variables over here on the left, there is no way to modify the variable. Also bear in mind, since we are in the level blueprint, the level blueprint itself does not have any components. Remember, we have no component tab over here on the left, so that's missing. And we don't have a construction graph, which sets up our blueprints before the game actually runs. Another note is that the delay node here does not actually pause the game. It just stops the execution flow for what is happening in the blueprints. So keep that in mind. Alright, so now I'm just going to go ahead and connect this bad boy to a quit game node. Now, we can go ahead and find this one manually by right-clicking the background and type in quit game. A match is different than a game. This is based on turn-based. We're going to quit the entire game, or you can be legendary like me and do it this way. I personally like to create nodes using a context-sensitive system by dragging pins off with left-click, letting go. So if we hold left-click and drag onto the black slate over here in the back, and then let go, I'm going to type in the word quit, and we're going to go ahead and quit the game. As you can see, our quit game, let me save. No, let's see. As you can see, our quit game has other input pins that we can use. For example, if this was a multiplayer game and I wanted to reference one of the specific players in the game, and then connected whatever their reference would be in this graph to the specific player node, it would cause that specific player to exit the game. This could be like for moderation, this could be for specific quits, this could enumerate all the characters that could load at any given time and then allow people to quit individually depending on how they were working, so on and so forth. There's also the quit preference variable here as a drop-down, which is hard-coded as well, where you can select the difference between quit being a full quit and background, which allows you to background the game without having it quit or vacate out of information, but just run in the background again. And then we have this button here, ignore platform restrictions. This is kind of dangerous. I'm going to read this one here. Ignores and best practices based, I don't know why it says and, it should say any. Ignores any best practices based on platform, e.g. PS4 games should never quit, non-shipping only. So if we were designing a game for PS4, the PS4 can't randomly quit. In order to meet and match CERT, which is certification for games, you cannot randomly quit a game without warning the player that you're actually going to quit the game for them. This works in production and works if we're not shipping the game, because sometimes we just want to quit out of a game and override what the PlayStation is going to do. However, in order for a game to be PlayStation certified, you cannot do certain things, like randomly quit without warning the player of what's happening to their information or what's happening to their play state. That would automatically fail CERT, which is TRC, either referred to as technical requirements for code or technical requirements for certification, or in games development we just refer to that as CERT or certification. Yeah, that's what this button is. This button can be dangerous, but since we're developing on PC, we don't have to worry about that. Alright, now that we have finished our code, and we don't have to change anything in here, this is fine. The most important thing that we can understand is we need to convert the logic into machine code that the engine can understand. We need to compile our code. Programmers, you probably already see it. Newcomers, that's this button up here in the top left. Does everybody see this fun, happy button that says compile with a yellow question mark on it? So, in order to compile the blueprint, we can use this button in the toolbar. And, like I said, you'll notice that it has the yellow icon. This means that, hey, this code is dirty, which means that what you are seeing is not what is going to run. You need to compile it in order for it to work. Let's hold Control-Alt. This will compile the current blueprint, which is default keyboard shortcut of F7. I almost never use that. Any errors or warnings will be flagged in the compiler results pane, and also any applicable node will have a red warning placed on it if there is a problem. Here's the thing. Compiling does not check to see if your code will actually execute the way that you want it to. Compiling protects the engine and the operating system against illegal operations, like syntax error, or an operation that might divide by 0. A compile is supposed to check to see the code if the code is worthy of the engine being able to run and run through its basic checks. If your code doesn't work, for example, if I don't correctly set up the ability to pick up an object, which is array cast, go figure, the code might still compile, but it still might not work in the world. So just because your code compiles does not necessarily mean that your code is going to work, right? All this does is converts it into code that the game engine is going to understand. Now, there are also slightly dangerous options up here. We can go ahead and save on compile. For example, by default, this is going to be grayed out. I'm going to go ahead and compile initially here. There we go. You cannot save on compile, I believe, in the level blueprint, because this is not actually a file that is able to be saved to. I wouldn't encourage you to save this. These options would be lit up for you in the default blueprints, but not in the level blueprint, I believe. What this does is essentially prevents you from saving over level blueprint stuff immediately. But essentially, every time you compile, you can set it to never or on success only, meaning that if the compiler finds no errors in your code, it will not save over your blueprint. But if it does, it will not save. By default, it's set to never, but you can always set it to always, which will always save your blueprint when you're compiling, even if there are errors. Generally speaking, if you become very good at blueprints, I would say on success only is going to be okay, because what it means is that you don't have to actually manually save. See, we've got our level blueprint up here that manually saves us as an asset. But essentially, this allows us to jump the saving element. And since this level isn't saved, I'm going to actually go ahead and file a save current level as here. Content new folder, call it maps. We'll call this BP demo map. Cool. Let's open the level blueprint. Now we can go ahead and hit compile, and if we want to, we can save, which should be relatively safe. And then we can go ahead and test out our code here. When I'm working on blueprints personally, especially level blueprints, I like to pick them up and drop them next to my levels so that I can actually see them in time. But typically speaking, I will also drag them over onto my other monitors so I can see the code execute at the same time. I'll see if I can demo that here in a sec. Let's go ahead and hop back to the map here, and let's go ahead and test out our code. So what's supposed to happen when we actually start our blueprint is that we're going to see the game run for how long? 3 seconds. So the game will run for 3 seconds, and then we'll exit back out to the editor. Let's go ahead and hit play and see if it actually works. 1 1000, 2 1000, 3 1000. And there we go. We saw that the editor did run. Now we're no longer in play mode. We're back in the editor mode. And let's go ahead and test it out again. 1 1000, 2 1000, 3 1000. Bam. Let me see if I can go ahead and bring up the other one. I'm going to pause here for a moment. All right. I got my blueprint window right down here, and I'm going to change my debug object to the BP demo map, which is what we're running in right now. And then I'm going to go ahead and hit play, and we can watch how this executes. We see our delay functions, and then our quick game fires, and then we are back in the editor. I'll show you guys more debugging tips and tricks when we get to debugging in the future. The last thing that I want to talk about in here is I want to talk about comments. Commenting is the secret to consistently being able to come back to your code and being able to annotate it. You can comment your code by right-clicking a node and saying, hi, this is a comment, and this is a delay node for 3 seconds. And that is one way to comment. The other way that I like to comment as well is I like to select elements, and then I like to press the C button, and then type your comment in here. I can't read it because I can't see. There we go. Pressing F2 will automatically highlight any text that you can edit. So you can comment individual notes. I'm different. Or you can comment families of notes by using this function. This is very similar to how in certain languages you can comment by using either the double slash or forget what other languages use to do comments, etc., etc. Why in the world would you want to consider commenting your code? Always comment your code. I cannot stress this enough. Always try to comment your code, especially if you're new. Because what this is going to do is this is going to help you figure out what you actually wrote and what your intention was when you actually have an opportunity to change the node. It's really important, just in general kind of cleanliness, that you should always comment your code. Programmers, you probably are staring at your computer like either you hate me or you love me for saying it. You should almost always comment your code. Even though it's blueprints, it is still code. Programmers, I know it's not real code. Just trust me, the worst case scenario is that you end up with a blueprint that doesn't work, and you don't know why, because somebody didn't comment any of the system. You're going to have to then read it and figure out how it works. As you can see, commenting our elements here, turn on the compile, we can compile, and then we can save once it actually compiles, and everything will work as intended. But it is somewhat helpful to always comment your code whenever necessary. Alright, that's going to be it for the introduction to blueprints. I'm going to talk about some variables and functions in the next few here, and we're just going to putt along until we're actually to our demo here, where I'm probably going to make that your homework. So let's go ahead and keep going, and I will see you guys in the next video. This has been the introduction to blueprints.